This is a demonstration of how to graph a polynomial that is already in factored form. So you can start pretty much anywhere you want, but this is where I'm going to begin. The graph is heavily dependent on the degree and the leading coefficient. These help you figure out what's called your end behavior. I have a video about end behavior if you want to go back and watch that if you haven't already. So your degree of your polynomial is the highest degree in standard form. Now this is not standard form, this is factored. However, it's very easy to find the degree of the polynomial. All you have to do is add up the exponents on each factor. So that x plus 2 is raised to the second power, but the other three, since there's no exponent, it's technically a degree of 1. So all you have to do is add up these degrees. So this polynomial is a degree of 5. What I'm really worried about is the fact that this is odd. So your degree is either going to be odd or even. Now you look at your leading coefficient. You're going to find that just in the very front. You're basically figuring out, is there a negative sign here or not? There isn't, so we know that this is positive. Now we have figured out that this is odd and positive, which leads us to our end behavior. If you have an odd degree, the ends of the graph are going to be going in opposite directions. If you had an even degree, they would be going in the same direction, either both up or both down. But since this is odd, they're opposite. Think of it that way. Now, odd positive looks like this. On the left-hand side, your graph is going to be going down. On the right-hand side, your graph is going to be going up. So that first line of your end behavior is asking you, what's happening on the left side of this graph? Where is it headed? Well, it's going down, which means y is approaching negative infinity. That bottom line of your end behavior, x is approaching positive infinity, means what is happening on the right-hand side of this graph? It's going up, which means y is approaching positive infinity. So now we already know some things about our graph. We know that the left-hand side is going down. We know the right-hand side is going up. Now we're going to figure out, where does this graph cross the x-axis and what's happening at each of those x-intercepts? So all of these factors get set equal to 0, and then you solve for x. So if x plus 2 is equal to 0, that means x is equal to negative 2. Okay, you subtract 2 to the other side, x is negative 2. I'm going to do the same thing with my other factors. If x plus 1 is equal to 0, that means x is negative 1. If x minus 2 is equal to 0, x is 2. If x minus 3 is 0, x is 3. Now, multiplicity just means how many times does this factor occur in my equation? The x plus 2 has an exponent of 2. That means I have 2 of them. So that means negative 2, which came from x plus 2, has a multiplicity of 2. I hope you were able to follow that. I said 2 a lot. But this is just based on the exponent where that x-intercept came from. So negative 1 came from x plus 1. This has an exponent of 1, which means it occurs once, so it has a multiplicity of 1. 2 came from x minus 2. It has an exponent of 1. 3 came from x minus 3. That also has an exponent of 1. Now, the multiplicity tells us whether the graph crosses or bounces at each x-intercept. So if it crosses, that means if it starts below the x-intercept, or sorry, if the graph starts below the x-axis, it's actually going to cross through to go above it. But if it bounces at that x-intercept, it'll just touch the x-axis, and if it's on the bottom, it'll just bounce and go back down. Or if you're above the x-axis, it'll come down, hit the x-axis, but then bounce back up. I will demonstrate what that looks like on the actual graph. Hopefully that made a little bit of sense. So if you have even multiplicity, the graph is going to bounce at that intercept. If you have odd multiplicity, the graph is going to cross at that x-intercept. So the graph is going to bounce at -2 because -2 has even multiplicity. The graph will cross through all of the other x-intercepts because they had odd multiplicity. Now I have everything I need to know. So what I'm going to do first is put my x-intercepts on the graph. Nope, that's not supposed to be there. Okay, sorry. Just ignore that one that I just put an X through. So I'm going to start with my end behavior. That's where I like to begin when I'm graphing these by hand. We know that the left is going down, the right is going up. We talked about that in the beginning. So on the farthest left x-intercept, I'm going to draw that graph heading down forever. On the farthest right x-intercept, I'm going to draw it going up forever. So that's what the ends of the graph look like based on the end behavior that we discussed in the beginning. Now, starting from the left, I'm going to go through or bounce off of each x-intercept. So on the previous slide, we said that this was going to bounce at -2. So as you're tracing this, once you hit -2, you need to bounce off of it before you get to the next x-intercept. Like that. So see how it bounces off, but then it eventually needs to head back towards the next x-intercept. At -1, we said that this was going to cross through, so it will actually go through the x-axis this time instead of bouncing back down. If you want to know the y-intercept, you would plug in x equals 0 and solve. Okay, I was really focused on more the x-intercepts and the end behavior in this video, but if you want to know the y-intercept, again, you would just plug in x equals 0. So once I go through my y-intercept, I'm going to have to come back down to my next x-intercept, which is +2. And again, we're crossing through 2. And once we cross through, we're going to have to get to our next x-intercept, which is 3. And like we said before, it should cross through 3, which it does in order to reach that end behavior on the right. So that is how you roughly sketch a polynomial with a degree of 5.